We want to solve 5 questions on quadratic equation, polynomial, and partial fraction. So this is the first question. It says show that a square s square minus as plus 1 equals 0 can never have real root. So what we need to show is that this can never have a real root. But now, before we go into the detailed proof, you need to note something, that a can never be 0. At the same time, s can never be 0. Why? If you assume that a is 0, this is the equation. We have a square s square minus as plus 1 equals 0. If you put a to be equal to 0, for example, into this equation, let me call it 1. If you put a to be 0, then you have 0 minus 0 plus 1 is equal to 0, which is impossible. 1 can never be equal to 0. 0 plus 0 at the left hand side, 0 minus 0 is 0, 0 plus 1 is 1, 1 equals 0 is impossible. At the same time, if you put s2 to be 0, you will get 1 equals 0. So that established the fact that a can never be 0. A is different from 0. Now, how can you show this can never have a real root? Let's come to the main question now. You just need to show the discriminant. The discriminant of a quadratic equation, b square minus 4ac. When you are given a quadratic equation, as square plus bs plus c equals 0. So the nature of b square minus 4ac will tell us how the root will look like. If it is greater than 0, you will have a distinct root, distinct and real. You will have distinct and real root. If it is less than 0, you have complex or imaginary root. That means it can never be real. And when it is 0, when it is equal to 0, you have equal root as well as a real root. So we just need to find this now. In this question, our a is actually a square. That's the coefficient of s squared. B is negative a, that's minus a, and c is equal to 1. So d is equal to b squared, that's minus a all square minus 4a square multiplied by 1, and this will give me a square minus 4a square. A square minus 4a square will give me negative 3a square minus 3a square, which will always be less than 0. Why? Because a square actually is always greater than or equal to, is always greater than 0 for all a in R, but when a is different from 0, it will only be equal to 0 when a is 0. So when you multiply negative 3 with a square, it becomes less. So since d is less than 0, the equation is complex. Since the discriminant d is less than 0, the equation is complex. It's a complex root or is not real. So another alternative way you can do this is so that you can see that so as to make the discriminant obvious is you have a square s square minus as plus 1 equals 0. Of course, I have already established the fact that a can never be 0. So divide through by a. When you divide through by a, you have as square minus s plus 1 over a. That is what you are going to have when you divide through by a. So the discriminant here will be b square minus 4ac. In this case, b is negative 1 minus 1 all square minus 4. A is a, obviously. That's coefficient of s square. Then c is 1 over a. So when you put 1 over a here, at the end of the day, you have 1 minus 4. The answer is minus 3, which is obviously less than 0. So you have a complex root. So this second way is actually an alternative method, not part of the equation. It's either you prove this way, this is method 1, and you stop here and make your conclusion, and it's not real, or you do this second method and you make your conclusion as well. Whichever one is fine. Let's go to the second question. So the second question says that discuss the nature of the root of the following equation: A, 3x squared minus 2x plus 4 equals 0, B, 4x squared minus 28x plus 49 equals 0, and C, x squared equal x minus 5. Of course, don't forget I told you before now that whenever you are talking about an equation and you want to talk about the nature of the equation, you just have to talk about the determinant, the discriminant, b square minus 4ac. Now, the first question A, we have 3x squared minus 2x plus 4 is equal to 0. Now, A is 3, B is negative 2, that's the coefficient of x, and C is 4, the constant. So, D equal b square minus 4ac, that is equal to minus 2 all square minus 4, a is 3, c is 4 as well. 2 minus 2 square will give me 4, 4 times 3 will give me 12, 12 times 4 will give me 48. So this will give me negative 44, minus 44, and that is less than 0. So the nature of this root is that the quadratic equation has a complex root or an imaginary root. The second one, we have 4x squared minus 28x plus 49 equals 0. So here again, a is 4, b is minus 28, and c is 49. So d, that's b squared minus 28 squared minus 4ac 49. So this will give me actually minus 28 square is still 28 square minus 4 times 4 16. Oh, this is same thing as 28 square as well, because 4 times 7 28, 4 times 7 28, and it's 28 square. So this will actually give me 0. You can evaluate it very well to find the square of 28 minus the square of 28. You will get 0 at your final answer. So the quadratic equation has a real and equal root. So here a is 1, b is minus 1, and c is 5. So d equal b square minus 4ac. B is minus 1 square minus 4, a is 1, c is 5. That is 1 minus 20, because 4 times 5 will give me 20. This is minus 19, which is also less than 0. So the quadratic equation has complex or imaginary, has complex roots. Do you understand? So that is for the second question. So for this third question, it says find the value of phi of rho for which this equation x minus 2 multiplying x minus 3 equal rho has roots that which differ by 2. So now I'll first start from here. I have x minus 2, x minus 3 equal rho. Open this bracket, or let us expand this. We have x squared minus 5x plus 6 is equal to rho. Now I have x squared minus 5x plus 6 minus rho is equal to 0. So in reality we have this is the quadratic equation we have. Let's call it 1. But don't forget they said that the roots of this quadratic equation differ by 2. So we'll say let alpha and alpha plus 2 be the root of the equation. Why did I say alpha and alpha plus 2? They differ by 2, so if you do alpha plus 2 minus alpha, the answer will actually give you 2. So we are very correct saying let alpha and alpha plus 2 be the root of the equation. Don't forget, when you add the sum of roots is actually equal to the coefficient of x, that is minus 5. Since the coefficient of x squared is 1, so the sum of roots is actually equal to minus 5. And what is the root? That's alpha plus 2 is equal to minus 5. So this is 2 alpha is equal to minus 5 minus 2. Minus 5 minus 2 will give me minus 7. So that alpha will be equal to minus 7 over 2. Let me rewrite it here. Alpha is equal to minus 7 over 2. Now, we need to find the row. Don't forget, product of root is equal to the constant, that is 6 minus 5. 6 minus row. So, don't forget again, the product of root means alpha multiplying alpha plus 2, which is equal to 6 minus row. But alpha is minus 7 over 2. That's I have minus 7 over 2 multiplying minus 7 over 2 plus 2 is equal to 6 minus row. This is minus 7 over 2. Minus 7 plus 4 will give me minus 3 over 2 is equal to 6 minus row. Now, let's continue. So, by the time you open that bracket, you have 21 over 4 is equal to 6 minus row. So, bring row to the left hand side and take 21 over 4 to the right hand side. So, you have row to be equal to 6 minus 21 over 4. Taking the LCM, I have 24 minus 21, everything over 4. So, row equal 3 over 4. And that is the final answer to that question. Let's go to the next question. This question says that what is the remainder when the polynomial this Sn plus nx minus 1 is divided by x minus 1. Actually, this is what they want us to do. Actually, we use the remainder theorem. Using the remainder theorem. So in reality, the summary of the remainder theorem is that you will take what you used to divide, that is x minus 1, equate it to 0. So x will be equal to 1. You find x. Then the polynomial function, let's call the polynomial function f of x to be equal to x raised to power n plus n with nx minus 1. So to get the remainder, just put the value of x to be 1. So we have f of 1. F of 1 will be equal to 1 raised to power n plus n times 1 minus 1. 1 raised to power anything is actually equal to 1. 1 raised to power n will always be equal to 1 plus n times 1n minus 1. 1 minus 1 will give me 0, so I will be left with n, and that is the remainder. The remainder to this question, or the answer to this question, is n. So we have a partial fraction here. They say express 8 minus 3t all over 10t squared plus 13t minus 3 in partial fraction. In this case, look at what you are going to do. 8 minus 3t all over 10t squared plus 13t minus 3. You will first check the denominator whether we can factorize it. If you look at the denominator, we have 10t squared plus 13t minus 3. So actually we can factorize this, because if you do 10 multiplied by negative 3, you have minus 30. What I am going to multiply together that will give me minus 30 will be 15 times minus 2. 15 times negative 2 will give me minus 30, but 15 minus 2 will give me 13. So I will say 10t squared plus 15t. Basically what I'm doing here is how to factorize quadratic equation. Do you understand? So then I have minus 2t minus 3. 5t is common in this first place. I have 2t plus 3. Then minus 1 is common in the second one. We have 2t plus 3. So by the time you are done factorizing, you have 5t minus 1, 2t plus 3. So that means what is here at the denominator? 5t minus 1, 2t plus 3. That is the first thing we have been able to accomplish. Now let's come again. We have 8 minus 3t all over 5t minus 1 all over 2t plus 3. After this, then we have to do it this way: a over 5t minus 1 plus b over 2t plus 3. Clear fraction. By the time you clear fraction, you have 8 minus 3 to be equal to a multiplied by 2t plus 3 plus b multiplied by 5t minus 1. So in reality, by the time you clear fraction, it means that you will multiply both left hand side and right hand side by the LCM, and the LCM is 5t minus 1, 2t plus 3. To get a, listen, to get a, you have to find a way of making b to be equal to 0, or you have to just find a way of removing b. And a way of removing b is to make the coefficient 0. So we will now say put 5t minus 1 to be 0. So t will be equal to 1 over 5. So anywhere you see t, put 1 over 5. So anywhere you see t, put 1 over 5. So I have 8 minus 3 all multiplied by 1 over 5 to be equal to a open bracket 2 multiplied by 1 over 5 plus 3 plus b. By the time you put 1 over 5 here, you'll be left with 1. 1 minus 1 is 0. So this will give me 8 minus 3 over 5 to be equal to a. The LCM here is 5. This is 2 plus 15. 2 plus 15 will give me 17. So that means I have 17 over 5a. Meanwhile, at the left hand side, I have 8 times 5 is 40. 40 minus 3, 37 over 5 to be equal to 17 over 5a. At the end of the day, by the time you solve, a will be equal to 37 over 17. That is the answer to a. Now, to find b, the same approach is what we are going to use. We will make the coefficient of a 0. So we'll say put 2t plus 3 to be equal to 0. So, and make t the subject, that means t will be equal to minus 3 over 2. So we have minus 3 over 2. So put t to be minus 3 over 2 in the equation. So I have 8 minus 3 minus 3 over 2 to be equal to a times 0, obviously, plus b multiplied by 5 times minus 3 over 2 minus 1. So minus times minus will actually give me plus, so that I will have 8 over 9 over 2 to be equal to b. What I have in b will be the LCM will be 2. 2 divided by 2 is 1. 1 times 15 is still negative 15. Then minus 2. So that I will have minus 17 over 2b. So the next thing I'm going to do now is, on the left hand side, I'll make this a single fraction. That is 16 plus 9. 16 plus 9 will give me 25. So I have 25 over 2 to be equal to minus 17 over 2b. So b is equal to minus 25 over 17. So therefore 8 minus 3t all over 10t squared plus 13t minus 3 is equal to 37 over 17 plus b, but meanwhile b is minus, so that's minus 25 over 17